Emily, you can up the music a bit. I can't hear anything.
Okay. Better now?
Yeah. What is this?
I can't hear anything. Any music? Do you guys hear music?
Are you serious? It's like my max already.
Oh, cannot hear Emily. Need to put some nice Shah Rukh Khan song.
Oh, you can hear me speak, right?
Yeah.
Then you should be able to hear my music.
No, maybe Zoom is doing some noise cancelling probably.
No, but
Voice
you're playing through the screen share. Oh.
I'm using another device.
It's probably doing some noise cancelling over there.
Okay, only the screen share person can actually share the device audio, right?
Let me see if I can play on my com to be better quality. Can you hear now?
Not anymore.
If somebody talk, you won't hear.
Can.
Let it play.
Until you can play the song. Okay, we'll ask Emily to stop.
Wait.
Now we can ask Emily to stop. You can start playing the flute in the meantime. Can you play or it's just for fun?
Play little.
Play then.
Oh no, not pro. Separately.
So Sentinel, this was the meeting that you left me for? This was the meeting you left me for, Sentinel? You like rushed out of this mad discussion.
Well done, Senthil. Engineering first.
Senthil, can you play the flute? Pause. This is so awesome. Good.
Eric, stop it.
Good, Eric.
So rude of you.
Like hearing loud.
Eric, I think you should share to everyone.
It's not disturbing.
Eric, share with everyone.
Your name to Eric.
Eric, share the image. We all put us on our.
Yeah. We can all use the same.
Stop it, Eric. Stop it. Stop playing, Eric. Hi, Kimaya. Poon, your picture is damn scary.
Hey, Poon is in Nishchal's house. And Nishchal has gone on vacation.
Hi, Jared. Hi, Jared. Say something.
What you want me to say?
I don't know. You are excited for today's session.
Yes, I'm excited for Academy always.
Yeah.
Hi guys, hello.
Oh my god, Santi, is that the Titanic?
Yeah, this is one.
Can you blow it,
The
Santi?
theme song is actually Matrix. Highly requested by William.
Look at Eric.
Jared, you are the next target.
Now, Eric, you need to hide below and you will be like squeezed up.
Wow, I'm nice. Hello.
Jared, look at Eric's screen faster. Can I take a photo?
Oh, what is that, man?
Right, you're looking like a tiny boy.
Eric, see your phone, see your phone.
Wait, you got a hold of your mustache. Hello.
Jared, why you off your video?
New design.
We will just wait for 2 more minutes and then we will start the session. So please get everyone on the line.
Emily, I think you need to unmute Hasan.
Where's the phone?
Jangan apa tanya?
Hasan, you want to share your screen?
Okay. But just Emily, please, can you enable? Emily.
Oh, give me a
Yeah,
moment.
please can enable. Yeah.
Let me check. Okay, try now.
Okay. Thank you.
Good luck, Hasan.
Thank you. Oh, can you see my screen now?
Not yet.
Not yet.
Let's see. You are screen sharing.
Maybe you wanna stop and reshare.
Okay. What about now?
Still no.
Still same. Okay, I will share the PDF file only. Is it okay now?
Nope.
No.
It's saying like has started screen sharing.
Yeah, but we cannot see your screen.
Have you shared the whole screen or you shared a particular
Yeah,
window?
I tested both. The whole screen.
If you're sharing using macOS, then you need to enable privacy settings for Zoom.
You know,
We tested this, right?
Yeah.
Maybe you just wanna quit Zoom and rejoin. Totally.
In the meantime, Sentil will play the flute.
Okay, over to you, Sentil.
I think in the meantime, Eric should tell a joke.
Until you're here.
In the meantime, Eric, you should social distance from Jared.
That's a good one.
Sentil, you are on mute. Please unmute and then start.
I kept on mute purpose, man.
Okay, I'll try to leave and come back again.
Yep. So for anyone who's just joining in, give us a couple of minutes. Technical issues.
Sentil, is that you?
Yeah, he's blowing through his nose. Okay, now you can see his screen.
All right, perfect. Emily, shall we start?
Yep.
Okay, let's get started. I want to welcome everyone to Aleph Academy. Hope everyone's having a fantastic Friday. I want to thank everyone for joining. Today, I'm really excited to welcome Hasan from Aleph Malaysia, one of our first regional contributors. He is a senior full stack engineer in Aleph Malaysia, and he's gonna talk about IoT today and has planned some really cool live coding demos towards the end of the session. So I hope everyone will hang around, enjoy, grab a bite, a drink, and enjoy the presentation. Over to you, Hasan.
Okay, thank you,
just
Janaka.
Hasan, just a minute.
Yeah.
I think Emily is gonna mute everyone just to make sure everyone behaves. If you have any questions, do ask throughout the presentation on the chat, and I will throw them at Hasan.
Okay, thank you, Janaka, for introducing. Actually, it's my pleasure today to contribute in the Academy of Aleph by presenting the Internet of Things IoT, featuring Raspberry Pi and do some live coding. My name is Hasan. I'm senior full stack developer based on Aleph Malaysia. I'm a master holder in information technology engineering, specialist of computer systems and networks. I'm also passionate in cloud and IoT technology, and especially in the Raspberry Pi device. Our agenda for today, we will talk a bit about introduction to IoT and its applications. We'll move then to the Raspberry Pi device, which I called the magic revolutionary device. Then we will list some special projects that I've been worked on them previously. Then we move to the demo. I will show some projects I already used in some projects and do some live coding from doing an application, a network application, and how can we deliver the IoT in the based on Raspberry Pi. We will finalize with the future state finishing. So what's the IoT? IoT, it's about the things around us which communicate based on Wi-Fi and transfer the data wirelessly. So any device can be smart and it will act and make a decision, for example, and do some intercommunication between other things. For example, if we have the fridge, for example, sense that there is no enough milk or there is no enough eggs, for example, it will order directly to the market to bring something missing. Also, the cars now, we see that it's be smart, the smart city, smart homes, all that is around the IoT devices. So mainly, I just need to list here three main fields about Internet of Things and it's related to. First of all, the hot tech now, the hot tech fields which are big data or AI, artificial intelligence and blockchain. These are related to Internet of Things because when we say Internet of Things, we have a lot of data around and we are facing big information to be analyzed, for example, and get information from this data. It's also about the AI, the smart things that we use in Internet of Things. Also, the image processing, computer vision, all the AI principles are also integrated with the Internet of Things. And also, I saw one of my friends that use all the Internet of Things as a blockchain node. So he used the Raspberry Pi itself, that we will talk about it later, as a node in blockchain and do the encryption and the stuff of security. The cloud platform also now, most of the cloud provider, they have a lot of services about Internet of Things. So they integrate some features. They provide some services like green grass in the AWS. You can just install the SDK that they provide on the device that you need to manage and you need to get the data from. And then you have a dashboard in the cloud. You can control whatever the devices are connected. The third main topic here when we talk about Internet of Things is the wireless sensor network. There are a lot of applications about the wireless sensor network, which are small devices act as sensors connected wirelessly between each other and transfer sense data like temperature, humidity, etc. Also images, we can transfer images. It's kind of wireless multimedia sensor network. It's also a principle of Internet of Things and based on it. Let's discuss about some applications around us and about IoT. First of all, the home automation. We all see how Google Home now contribute in the home automation and make all the devices around us smart, connected via hub wirelessly, and can control whatever we want by just one click remotely. It can also act as smart devices and make some decision if necessary, the lighting, all that. Also, there is an open protocol we can say as standard. The KNX platform use it. It's about automation, not just for home automation, for anything, for building, for hospital, for whatever. But also in home automation, it has many devices can be configured and can be connected using the KNX as a protocol for communication. So we can make any device connected to the KNX if he provide the protocol to handle the connections between the devices. Other kind of applications now they are using the IoT in is the healthcare. Actually, there are some applications related to remote patient monitoring, like tracking the patient. So the doctor provide the patient with some devices to put it around his body to get the temperature for the body, the heart pulses, for example, and do the monitoring remotely. So it will reduce a lot of touch with the patient. There are also the hospital, smart hospital are running also in IoT devices. Another kind of applications are the surveillance applications. So the government, for example, can monitor its country, the country borders, if there is any motion detection in specific area. So these sensors will send notification for the higher level, for example, for another level of sensors, which are the cameras, for example. Then the cameras, if it detect any strange thing, it will also escalate the problem to the higher level, which is the video monitoring, because the sensors or the devices in these kind of applications are not connected directly to the power supply. So it needs to be reduced to reduce the power consuming. So we just alert the higher level of the processing, the camera and the video camera, based on low level and low energy devices notification. We also see examples about using the IoT in traffic monitoring. So some of countries uses the IoT and the cameras around the city to monitor the traffic around the city, and the traffic light now are smarts to close and to open based on the traffic in the original system that they all connected to. Last and not least is the environment applications. Actually, some of wireless sensor network applications are to monitor the temperature in the forest. So it will prevent the fires to scale, because we can spread some sensors around the forest, and when any sensor sense that there is a high temperature, it will send notification also to the administration or to the fire station, so they can control the fire. Also in agriculture, they use the IoT, for example, to humidity sensing in the soil and in the farming work. Also for water monitoring to the planets. All these can be controlled over the IoT. These are just samples of the applications. Now let's move on the Raspberry Pi as a device in the IoT. Raspberry Pi is a small credit card sized computer developed in the United Kingdom by 2012. Actually, it's a computer, but at the same time, it can be considered as it's not microcontroller. It's above the microcontroller. It's cheap. It's small. It can be connected connected to some sensors and some engines, but still can be considered as a computer. It's run on Raspbian. It's one of the Linux distributions. It's similar to Ubuntu, for example, but it's lighter because the resources of Raspberry Pi, it's not as the laptop and the computers. We can connect sensors and engines, as I said, directly to its GPIO, its general purpose input-output, which are these pins. So we can connect here some motion detection sensor. So if it sends any motion, it will notify the board or the processor, which will take some actions and connect to the base station or to send the data to anywhere. It also can be, we also can connect here some engines, some humidity sensors, the temperature sensor, whatever. Here is the processor of the Raspberry Pi. It's ARM. It's not Intel or something like it. It's similar of the mobile processors. We have the RAM memory here. Previously, we have 1 gigabyte of RAM in the Raspberry Pi 2 and 3, but now in Raspberry Pi 4, they support the 2 gigabyte RAM and 4 gigabyte RAM. And this month, recently, they announced that they support the 8 gigabyte RAM. So this small device has 8 gigabyte RAM, so it will be very powerful to use as a computer itself. We have here the USB-C power supply. We can connect here the charger, any mobile charger, or the power bank itself can be as a battery for the Raspberry Pi. Here we have micro HDMI to connect to the monitor if we need. We have the USB ports, USB 2 and USB 3. And we have the Gigabyte Ethernet, and we have also a Wi-Fi module, built-in Wi-Fi module on the board, so it can be connected directly to your router and have the internet access and do all the networking stuff. We have a lot of types of Raspberry Pi. This is the latest one, Raspberry Pi 4. We have smaller device, which is the Raspberry Pi Zero. It's used more for the IoT, actually. It's because it's low power consuming, but it's also low processing or low resources. So it depends on the project that we are run to use which kind of Raspberry Pi we can use. So this device, you can, this is the components of the Raspberry Pi if you need to set up. This is the board. This board is the Raspberry Pi 3. We have here HDMI, full HDMI, the big slot. We have the micro SD card. It's for it acts as a hard disk for the computer. So you can install on it the operating system, the Raspbian one, and put it inside the slot here in the Raspberry Pi, so it will run based on this operating system. We have also the charger, or as I say, the power bank, which make this board run. And we have some accessories like the box to protect the device from damage. We have also maybe can connect some terminals, mouse, keyboard, the camera. We have here slot for camera. We can connect it directly to Raspberry Pi, so it will act as a camera itself. So when we need to run this and see the operating system, see the desktop of the Raspbian, we need to connect. We have multiple ways, actually. We can connect it directly to our monitor and connect the mouse and keyboard, and it will act as same as any computer, any PC. So you can run you can just plug in the charger and it will run, and you can see the desktop directly. Or we have another way to set up, which is the headless. So we can just configure the operating system inside the micro SD using another machine to connect directly to the router that we have in our home. So we can just update some files inside the operating system files inside the micro SD to put the IP to put the username and or the SSID and password of the router and the IP. So once it will boot up the Raspberry Pi, it will directly connect to the Wi-Fi, so you can reach this device remotely using Wi-Fi. There are a lot of ways also to do that, but I just need to explain these two ways. Why we are choosing Raspberry Pi? First of all, the Raspberry Pi itself is a very good device because it acts as a mini computer. It's useful for teaching, training, and doing some robotics also. We have a lot of examples to use Raspberry Pi as a robot, as the brain of the robot, and also we can connect engines to the pins, as I said. It's at the same time, it's cheap and efficient to use in IoT and AI field, especially because we can connect the camera directly to it. For example, if we need to go with Arduino, the Arduino, it's difficult and complicated to connect the camera directly to the board. But here it's just one slot and you can get the camera on. So it's efficient. It has the resources to do some actions, to do some image processing, for example, in computer vision, in AI. All these can do it, and it's at the same time, it's a mini computer. We can also consider it as a server, web server also. We can develop whatever you need, Java, Python, Node.js. Also, it can do, especially after the 8 GB version. Now let's move to the special projects. I'm not sure if there's any question until now, Janaka. Or...
no questions.
Okay. Okay. So let's go now.
So I think everyone completely understands what you're saying, or doesn't understand you at all.
Okay, no worries. Now let's go to the special projects. Actually, I supervise on a project which is called Smart Intercom. We use the Raspberry Pi as a device to connect the camera to it and to broadcast a network. So this Raspberry Pi, it acts as a router also. It can broadcast SSID, and we can, using mobile application or mobile phone, connect wirelessly to this Raspberry Pi offline without any connection to internet or third-party server. So directly we can connect the mobile phone to the Raspberry Pi. So we developed also an Android application to connect over socket. We developed a program in both sides using socket programming, so we can transfer the data, the images, the videos, streaming directly between these two devices. So whenever this device, the Raspberry Pi camera, can detect motion, or the motion detector here, we have a sensor as a motion detector. When it sense there is a motion around the home, it will send a notification to mobile to know that there is motion around you. Then if anybody click on the button, the camera, it will start capturing, it will stream the video, and it also can do some face recognition algorithm. Yes, Raspberry Pi can do this kind of algorithms. We provide it with some pre-trained models in AI, and it will recognize the face if it's already predefined in the system or not in its own database. It also can contain database. So all this we implemented from scratch. This was as a product, if you can say. Another project, which is the Smart Mirror. I don't know if you have, you know, the Smart Mirror. Now it's a common, but 2 years ago it wasn't. The Smart Mirror, it's a device, it's a monitor, it's just a monitor, but we put a two-way mirror in front of it. So it will make the light go through in one way, but the other way it will act as a mirror, because the background of the monitor, it will be black. So it will act as a mirror, but it will throw the light. So we can read what in the monitor itself. So we put the two-way mirror, we put a frame around the monitor, and also it can be connected to a webcam. And this Raspberry Pi is the device which run the smart mirror that we will show it in the video I will share you here. I'm not sure if you can see my screen now. Still, right? Can you see my screen now? Hello?
Yeah, we can.
Okay, sorry. So this is the smart mirror. It's mirror, as you can see, but it can be also configured as a Google Assistant. It connected directly to the lights.
Hey Google, what's the weather this afternoon?
It can act weather also.
Hey Google.
Here we have the weather. I don't know if I think you cannot hear, but I'm explaining what the features here. There's the news. There are the news of today. We have here the calendar. We have here the weather outside. Here we can control the lighting around the home. Maybe we can ask the Google Assistant to play some songs. And we have here also the LEDs also are connected to the Raspberry Pi to show that the Google Assistant now is listening or acting what I asked to. So this magic mirror, we can call it, actually it's open source project published on GitHub. So we can install it, clone this project directly to Raspberry Pi, and it will act the same of what we just see in the video here. So it make some easy for the life. It can be synced with our calendar. So when we want to go out from home and we need to brush our hair, we can see what the calendars and the weather outside and some news. So it's kind of commercial projects we worked on.
So
yeah.
First of all, is the video of your house? Is the mirror yours?
No, it's not mine, but we did the same mirror. I can send a video of mine, but I didn't put it because this video is linked to the lighting. But in my home, there is no lighting, smart lighting yet.
Okay.
So this video is integrated with the Google Home, so I prefer to show it.
Okay, let's quickly take a question from the audience as well.
Yeah.
There's a question from the audience asking what kind of applications IoT can help during this COVID-19 pandemic era?
Actually, last week I saw that there is a project run nearby about face recognition if the patient put the mask or not. So it recognizes the face if the person or the people around the market or around the mall, if he follow the rules of the government or not. So this was based on Raspberry Pi also. So you use the IoT based on Raspberry Pi to implement this computer vision application, smart application to handle this issue.
Was that in Malaysia?
No, it's not Malaysia. I just saw it over the internet of my friends. They just implement the algorithm of recognition.
Okay, awesome.
Yeah,
and I think Druel has also shared on the chat. I think an important application is contact tracing.
Contact tracing actually also it's one of application. I don't remember what who implement this feature, which country implement this, but it can be also used. We can also use the IoT as contact tracking. So using Bluetooth also to know if I get in touch with COVID-19 patient or not. So yeah, it's useful in the current situation also.
All right.
Okay. Then another commercial application. Actually, this is out of scope of the IoT, but I prefer to mention it here because maybe we can use it in our clients with our clients, which is the thin client. This thin client concept, we run the Raspberry Pi as a thin client in banks and government big centers, which contains a lot of people, a lot of employees, and have the same images for all their PCs. So we proposed to use the Raspberry Pi as a computer connected to the server by network, and it will act as a full computer. We connect the Raspberry Pi. The Raspberry Pi itself, it cannot be a workstation itself and do the programming and the designing, but we can connect over the network to the server using RDP, for example, remote desktop protocol, or the VDI protocol, which is virtual desktop infrastructure using VMware technology or whatever. So it will make the maintenance of the whole infrastructure of the computers cheaper, and the maintenance will be also easier. So all the applications and all the processing will be on the server. So whenever employee come to the institution or to the center, we just provide him with a Raspberry Pi, which is cheap. Now the Raspberry Pi costs about 36 USD. It's the global price. So it's so cheap if we need to compare it with the personal computer or any laptop. So we also use this as a thin client, the Raspberry Pi. Let's go to the final application that I worked, which is the research. In the research field, also I did my master around the IoT and the Raspberry Pi. I actually run about 7 Raspberry Pis connected wirelessly as an ad hoc network. This ad hoc it's kind of network type, so there's no one hotspot and the other are connected to this hotspot. There's no centralized node in the network as a router or access point. No, every node here can connect directly to the nearest node. So this node, if it needs to send the data to the workstation, to the person here, the monitor, it will send the data over multi-hop until it will deliver the message that it wants to deliver to the sink. This is called sink in the wireless sensor network. So this application, what I contributed here in the master, is to securing these communications, because the security is it's a key player in the IoT environment, because a lot of devices are limited of resources, so it cannot do the encryption and do high level of cryptography or whatever. So I use the Raspberry Pi to do some encryption, to do some hiding the information, and I implemented a protocol which runs on the Raspberry Pi to deliver the images that it captured to the sink, to the internet, we can say. So we apply this into the car plate number recognition, as I will explain it in the demo, next demo. So any device capture this car plate number, it will do some encryption and hiding the information, and will send to the next hub, and the next hub will send to the nearest next hub, etc., to reach the computer that we are monitoring the whole network. So we use also in-network processing because of the power of Raspberry Pi. It can be used as an in-network processing. So we can process the data while it's transferring, not just sending the data as low-level devices in the IoT.
So
yeah, before we go to the demo.
I think that's another question. I'll frame it this way. Is there enough computing power inside the Raspberry Pi to do face recognition on the device, or do you need to send the information to a centralized server?
That's the main feature that we implemented. Yeah, we can do the face recognition inside the Raspberry Pi itself, and we implemented this in one of the academic projects that I supervised. So we provide it's not work as a training. We just provide it with the trained model. So it just will compare if it's this face is recognized in the system or not. So we use it, yeah, over one project, and it will work in efficient way.
Awesome.
We use a Python because Python it has a lot of libraries, third-party libraries for AI, and now it's the #1 programming language in the world. I think because of that, because it's integrated with AI more than any other programming language. So using the libraries of Python, yes, it can do this.
All right.
Okay. So let's move now to the demo. First of all, now I have near of me a Raspberry Pi, and I connected a camera to it. And this is the Raspberry Pi desktop. Now I'm connecting to the Raspberry Pi wirelessly over a program called VNC Viewer. If you know it, it's a VNC Viewer. This is the Raspberry Pi that I'm connecting to, and this is the desktop. It acts as a remote desktop, okay? So this is the device is near me. It's connected directly to to my laptop. Now this is the desktop. It's similar for Ubuntu, I think. We have here the menu. As I said, you can connect it directly to a monitor, but here I'm connecting it over the VNC. Here we have also a web browser. You can see whatever in the internet. We have this is the VNC viewer that I'm running on it. We have some games to games lover. We have the programming here, the Python. It's built-in programming language. It's been built in IDE inside the Raspberry Pi. It's inside the Raspbian, I mean. And we have this Scratch program. I don't know if you know about Scratch. It's basic programming languages. It's for learning programming without do coding. Okay, it's for teaching kids how to program, and to those who need to start learn programming, I advise them to start from here. For example, we can. It's out of the scope, but I really like the Scratch IDE to start with if you want to learn how to program. So, for example, just a bit here, we can when I click start here, the cat will move 10 steps and repeat that 10 times, for example. So the cat will move. If we can increase this to 20, for example, it will move longer. So this is the repeat that we know it as a for loop or loop or while, and this is the action. It's just an example I wanted to share with you. So maybe you can, if you have children to need to teach them how to program, you can do this in Scratch. This is a cheap device, and without buying a new laptop for the children, you can do this here. Also, as I said, you can surf internet over it. Okay, this is the Scratch. It's from MIT in USA. Now let's have a photo here. Let's capture an image. I will run the terminal now. It's like any Linux terminal. I will go to the desktop, and here I will capture an image. We have the rasp still. This is a command in the operating system that we can capture an image directly from the camera, which is connected to the Raspberry Pi board. So I need to make the output as a photo.jpg. now it's capturing the image. It has a red light, so when it's run, so it will it's capturing the image. This is the photo that it captured. If we can run it, this is one. So if I can do any capture, also if I need to resize the image, I can configure this in the terminal itself. So additional image here, you can share. This is for me introducing. Okay, this is the one command to have an image directly. This live. Okay. Actually, we can also have we can write a program using Python to capture an image. It's just one library. We can import it and do this capture imaging.
Hasan, so do you think you can show, like, share your video and show the device to make, like, show everyone that you're actually running this live?
Yeah, I think I can share my video in the Zoom. Okay, I'm afraid if when I turn on my video, the screen sharing will be off. Yeah, because previously it wasn't work.
I see. Okay.
Okay. Now let's go to another example, which is computer vision. We use some library, which is this code. Test played. This is a library. It's ALPR. We have the Open ALPR library from GitHub. I installed the library in the operating system, so I can use it as a library. I import the system is just for doing some analysis here. This is the way that I initialize the ALPR algorithm. Okay. This is also, it's all about the setting the environment to make the program run using the Open ALPR library. And here in this command, I'm telling the program or the Raspberry Pi to recognize this file, which is the 4.jpg. Okay, this is this car. I have an image here for the car. This car, I just put the photo name or the file path here because I'm running it inside one folder, so no need for the full path. And I put this if there is a results inside the results of this function. I just need to print the first candidate plate number because it can list for top 10 matching plate numbers. So I just pick up the first result and I print the result, and then I unload the ALPR library. So if we need to run this program, okay, I will just turn the terminal, go to desktop and do Python testplate.py. Now the program is run and the algorithm it's executing here and searching on the plate number first. Then it will, like on OCR, it will extract the number of plate in the code. So this is the number of plate, as you can see, it extracted. So this is one of the examples that we can use computer vision inside the Raspberry Pi without any server behind. The Raspberry Pi itself can do all this.
Awesome. So if you could flash the test plate Python script again. There's one of
code.
Yeah. So one of our designers are asking, how can I get started coding in Raspberry Pi? I just want to flash this and see it's just not more than 10 lines of code, I guess.
Yeah. Just this kind of code, it can do all this processing and can featuring of the image. Yeah. So, and also I will write the next demo. It's just five lines of code. It will send a message from one device to another. So yeah. So it's not
very easy. It's very easy to get started.
Yeah, and Python, it's one of the easiest programming language to start with. It's not complicated as Java, for example, or C#. It's just write and execute the code without any structuring like in the Java or other programming language. So this is the last application. Actually, I wanted to write live coding, but I think the time is a bit not too much. So I will run the program directly. This is the sending messages over network, which is related directly to IoT, which is connected the devices over the network. Here I will consider my laptop here that I'm showing as a server. So this server program I wrote here using Notepad, okay? This kind of program, which is considered as a server, which will receive a message from the Raspberry Pi, which is considered as a client. This server, we use socket programming. We just import this socket, print that the server is starting. It's just for showing the status on the terminal. Here we connect to the socket. We define the socket as a server socket. We are running on IP address and do the socket streaming with connection oriented. This is in details. We can speak about it later. It's just network concept. Here I'm binding that this application that I'm writing here will be run on the port 10,000. So any client will connect to my machine, to my IP, and put this port. It will connect it directly to this application. Here I put that I'm listening to 5 clients only, and here I accept a connection. So the execution of the program will still here, wait here until any client will connect. We will see now after this, or now, we will see now how is the program written in the client. Because when we write a server client application, it's good to write the server first and the client. And once the server needs to receive an image, we need to send it from the client. And when the client needs to receive the message, we need to write the send in the server. So until now, the server here is waiting any connection to connect it to the server, to the IP. So this is the client. As you can see, it's just 5 lines of code. Here the import, we import the socket library. Here we define an object from the socket. We connect to the IP of the server of my machine, the machine I'm running on. And this is the port that is defined there. So I just s.send, I send this message, hi. So when I, before I send, here in the connect, what will be happen? When I connect here, this will be execute, will accept this connection. So once we accept this connection, we will move to the next instruction. Here we have just address, the address of the client that is trying to connect. And here we print any received data with size of this buffer size, put it 1024. So here I am receiving some data and printing it. This data received by this instruction, the send command. Here when I send hi, this will be executed, the receive one. Then I send back a message for the client, thank you for connecting, and I close the socket. This I print the received message from the server, and also I close. So simply, I just run this program, open PowerShell. Here I will just do Python, the server. Now it's starting the server as we printed it. And here I will go to the desktop and run Python, the client. Now it sent the message, if you can see here, that he received, the server received the hi message from the client. So this is just a short example about how to send the data as a string between 2 devices. And we can consider my laptop as a separate Raspberry Pi. So the first Raspberry Pi, for example, sends some temperature, some humidity information, and need to send it to the other device. So we can follow the same implementation. That's the last the project that I need to share with you.
Awesome.
Last,
Let's quickly try to get a question in.
okay.
So there's a question about whether they can integrate their own deep learning models to run in the Raspberry Pi. I guess that ties back to the face recognition kind of stuff that you discussed earlier.
Yeah. Actually, it uses Python. So whatever you can do it in Python on your local machine, you can do it the same on the Raspberry Pi. So you can consider the Raspberry Pi as a separate computer. So how you do it in your local machine, you can do it on the Raspberry Pi.
Exactly.
Okay.
And I know you're going to lightly touch this right now in your next slide. So there's a question about how to manage, like in a real world application, you're probably going to manage a cluster of Raspberry Pis or devices. What are the kind of, I think you're going to talk about this right now. Right?
Yeah. I will talk now what the next. Actually, the future is coming, not the winter. So we need to prepare because IoT it's going to our life and indeed around us in all what we do. It will control the future. All the devices around us will run over network and it will be smart. Now, as I said, most of cloud systems are integrated to the IoT things, IoT devices. So now we can, answering the question, we have now some services in AWS, for example, or Microsoft Azure to monitor or to control a cluster of nodes using SDK. We just download the SDK from Greengrass, for example, in AWS and install it on the Raspberry Pi. By the way, the Raspbian, it's supported in the Greengrass also. So you just need to install the SDK on Raspberry Pi and it will be controlled by the cloud. So yeah, I know some people make a cluster of Raspberry Pi to work as a server, a real server to host many applications, many web applications for the production also. So yeah, we can control it using cloud. Now the last thing I wanted to share with you is the edge computing. Actually now it's also a research field. It's to move the Internet of Things in almost most of its applications. It's centralized. The processing it's centralized in the server. So the sensors or the devices, it's just for collecting the data and transferring it to the centralized device, which will do the storage and the processing and the analyzing. But the edge computing, it push the processing to the client side or to the terminals or to the devices itself. So I think the Raspberry Pi is the best choice to do this linking between these two concepts or to these fields, because it's work as an Internet of Things and sensing and capturing all the data it needs in the Internet of Things, and it also can do the computing thanks for the resources that it has. The processor, which is 1.5 gigahertz, it's so good, and also the memory, the 8 gigabyte memory, it's so good also. So it also maybe it will work fine with the edge computing concept. So that's all from my side. Any question?
So I have a question. What are some of the commercial applications of edge computing? Are you referring to things like refrigerators, washing machines having computing power connecting to a network? Is it something like that or something?
We can do, for example, if we can talk about the monitoring system, as I said, the camera at the Raspberry Pi which, will capture the images and do some processing. So if there's no important data there, no need for sending it to the server. Or for home automation, I don't know if we can implement this because edge computing, it's for enterprise application more than it's the home automation thing. But yes, Raspberry Pi, we can connect it to Fridger also, providing the camera which will capture the milk, for example, milk bottle, and do some image processing to check if there is enough or not. So we can make a lot of things using this magical tool, as I mentioned before.
Okay.
Any other question? Because now I think it's 6. We
Yeah.
just end.
So perfect timing, Hasan. Let's give the audience a couple of minutes to ask questions on the chat. Okay, so there's a question. Well, what are the security concerns related to IoT? How do you ensure adequate security and privacy measures?
Okay, good question, because it's one of the big challenges actually in IoT devices to implement the security issue. So the data, because you spread the devices in the open space, so anyone can access to it and just try to sniffing on the network, for example. And we faced something like this previously. But also thanks to Raspberry Pi, we can implement the encryption algorithms and do cryptography, and also do some steganography. I used steganography approach to hide some information inside an image that I send over the network. So because it has the high level processing and high level of memory, so it can do some encryption algorithm. I prefer to use actually the symmetric encryption, because when I tested the asymmetric encryption with long key, it takes about 3 seconds to encrypt just one image. So but when I tested it in symmetric encryption, it will just take milliseconds to encrypt the image and send it.
Okay, perfect. So let's see if any other questions from the audience. If you guys have any questions, please post on the chat. In the meantime, so there were a lot of, there was one question before about where can I get the source code for some of these projects. So I just want to inform that a recording of this presentation will go on our YouTube channel. These slides will be available on our SlideShare account, and it will be posted on LinkedIn. And there usually is a follow-up post on our Medium publication about the day's proceedings. Sorry, I got a call. So these 3 avenues, you can find all the information that was shared here today. And also, if you really want to ask any specific questions, you can address it directly to Hasan, or you can email us at academy@alephLabs.com. Yeah. So we'll be around for a couple of minutes to answer any other questions. You can post it on the chat. Hasan, anything else?
That's all from my side, and thank you all for joining. I really appreciate, and I hope that you get the benefits of what I said. And if you have any questions, just ping me and drop an email for me at hasan@alephacademy.com, so I can answer any question you have. And thank you again.
Yeah. Perfect. I think you have a fan club from Malaysia. People are showing a lot of love on the chat for you.
Okay, good.
Yeah. So on behalf of the Academy team, I would really like to thank Hasan. He has been working with us the past month to do this presentation. We've been doing a couple of dry runs, sharing ideas. And to me personally, Hasan, thank you, because this is some of the ways I got inspired in software engineering as well. Most of our projects started in this way, software programming through mini computers like this, Raspberry Pi, Arduino. So it's really nice to come back to this this kind of programming. So
Thank
on behalf of William, Emily, and me, thanks a lot for contributing to our Academy platform. And I would really like to welcome other speakers to our platform. We have a Medium publication. If you want to write anything on our publication, contribute to our publication, please drop us an email. We have a YouTube channel and a SlideShare account where we all publish this information. So everyone is welcome to work with us to put out something that can benefit our Aleph community. Yeah.
Just a big thanks from me to William for help. Actually, he helped a lot, and thank you for make this happen and give me the chance to present here. So thank you for all your efforts.
These slides are beautiful, aren't they?
Yeah, William. Thanks, William.
Yeah, Emily, William, anything to say? Anything else to say?
All good, Janaka. Good job, Hasan. Well done.
Thank you, Wahid. Thank you for joining.
Thank you, Hasan.
Thank you.
Thank you, Hasan. Thank you very much.
Thank you,
Hasan. Thank you.
Thank you all.
Okay, thanks, guys.
Thanks, guys.
All right. Thank you, everyone, for joining. I think about 90 people joined today. So let's end the session now. Thank you very much.
Thank you.
Thank you, everyone.
Thank you. Bye. I love you, Hasan. Bye.
Bye. Thank you.